Okay, this is the introduction for the Energy and Storage Transfer Lab, and what we're essentially going to be doing is we're going to be taking a cart and we're going to compress a spring that's inside the cart, and we're going to say that that cart can do some work. The work that it can do can be turned into kinetic energy, and it can make a cart move. So what you're going to do is you're going to do a setup kind of like this, where we've gone ahead and we've taken our cart, and we've compressed a spring, as you can kind of see right here. We know that the work that this thing can do is going to be equal to 1/2 multiplied by k multiplied by x squared, where k is the spring constant and x is the amount of compression. What we can do is we can then fire this thing off, and the cart's going to take off. It's going to acquire some velocity. It's going to acquire some kinetic energy. The kinetic energy is 1/2 mass multiplied by the velocity of the cart squared. The velocity of the cart, we can read that off of the velocity versus time graph simply by using the examine tool. So you're going to do that as you've done in the past. You can measure the mass of the cart using the scales at the front of the room as you have done before. So we can calculate the kinetic energy that this thing had. We can also record the amount of compression that we had, and if we know what the spring constant is, we can calculate the work that is done, and we can say, wow, gee whiz, look at that, the work that was done is very nearly equal to the kinetic energy. The first thing we need to do is we need to figure out the spring constant, so let's talk about that. First, here's what you need to do the lab. You need a computer with Logger Pro, you need a motion sensor, you need a cart, you need a level, and you need a force sensor. And if you're really good, you notice that I have changed this from the one that I printed out for you. Sorry about that. So first part you're going to do is you're going to calculate K. You're going to take the force sensor, you're going to plug it in, and you're going to set it to the 50 Newton setting. You're going to fire up Logger Pro and make sure that everything is working fine. The very first thing you're going to do is you're going to zero the force sensor. You're going to zero it once, and you're never going to zero it again. Just make sure that no one is touching it, looking at it, or anything like that when you zero this thing. Then we're going to apply a force to this thing, and we're going to measure the force as well as the compression. Now, I've got some fancy brackets right here, but to be honest with you, you don't really need these brackets. What I've found is if I go ahead and take my force sensors and I set them up on their side, that they're going to line up with the cart just absolutely perfectly. One thing I'll note about the cart is you can kind of see the spring right here. Some of my carts have black on both ends, some of the carts have black on one end and silver on the other. You want to grab the ones that is silver on one end, and there's a little button right here that's going to release this spring. So all you're going to do is you're going to say, okay, the initial position of this cart is 16 centimeters, and I'm going to compress it by 1/2 of a centimeter, and I'm going to measure the force. Let me show you a top-down view of this. So here I've got it sitting at 16 centimeters. You can kind of see it right there. I'm going to compress it by 1/2 of a centimeter, and I'm going to read the force that this force sensor puts off. Where are you going to read that? Well, if you go ahead and you look at the screen, just right here, we have the force that the force sensor is reading. So what you're going to do is you're going to just record the force and change in length for several different compressions in this table right here. What you are going to do next is you're going to go ahead and plot the force against the change in length. To do this, you're going to have to do some manual data entry into Logger Pro. The easiest way to do that is just to unplug the USB, and the Logger Pro will do exactly what you want it to do. So what we can do is we can kind of say, well, I know that as my compression increased, the force probably went up, or at least logically so. I'm going to put my force against the y-axis and my compression against the x-axis, and my data points are more or less going to go up in a nice pretty straight line. You can say, hey, Logger Pro, fit a nice pretty straight line to that. And it's going to say, well, y is equal to mx plus b. And if you think about it, I've put force on the y-axis and I've put compression on the x-axis, and the slope then is going to look a whole awful lot like the spring constant. Just for the record, for my carts, your spring constant should be in the 100 Newton per meter to, I think, about 500 Newton per meter range. If you calculate your spring constant and it's not in that range, you really better flag me over because we'll have to talk. Now we're ready to go ahead and prove the energy is indeed a conserved quantity. At this point, you can actually just ditch the force sensor and just launch off of the stopper at the end of the track. Go ahead, plug in the USB, and as I said, you can get rid of the force sensor. It's a pain in the butt to use those brackets. You are going to make sure the track is level. That having a level track is very, very, very important to this lab. As with the last time you use these levels, the bubble gets you kind of close, but still, go ahead, get it level according to the bubble. Give the card a push in one direction, give the card a push in the other direction. Make sure it doesn't preferentially go in one direction or the other one. Now you're going to go ahead and record the mass of the cart just using the masses in the front of the room, and we're going to record the change in position just like we did for the previous experiment. We're going to compress it by several different amounts, and we're going to measure the velocity for several different times. So you're going to more or less fill this table out. You're going to compress it by several different amounts. Make sure the very last time you do this that you're compressing the spring pretty much the entire length. The velocity, you're just going to read that off of the velocity versus time graph, and you're going to calculate these guys as I mentioned. The kinetic energy, you're going to say 1/2 mass velocity squared, and the work of the spring is going to be 1/2 kx squared. Up here, you're going to be showing me a sample calculation just of each one. You don't got to show me every single calculation. And last but not least, you're going to calculate the percent difference. Just for the record, the percent differences are going to be probably in the 40% range for this lab. If you think about it, the kinetic energies are going to be relatively small. The work is going to be relatively small. It's hard to measure small things. So the percent error is going to be quite large. Don't worry, I'm not going to ding you for it as long as all of your calculations are correct. That's just a heads up. Now, if you don't get around to calculating the work and the kinetic energy of the spring in class, that's okay. Pretty much all you really have to do is measure your x's and measure your velocities, and then you should be able to go from there. All of this stuff right down here is stuff that you can do a little bit later. This one right here, you may need to ask me about. Most people need a nudge in the right direction.